Glass analysis is the application and analysis of glass to determine details about a crime. Glass can be analyzed to understand its origin using comparative analysis, which may include measurements relating to physical match, refractive index density, and elemental analysis. It is also possible to analyze glass fracture to better understand the angle, direction, and sequence of force as well as the projectile used. The purpose of glass analysis is used to detect the origin of the glass, compare fragments recovered at a crime scene to those found on the suspect, determine the angle and force required to break the glass, and establish the sequence of events, and to possibly determine the angle of trajectory of the projectile, shedding more light on the crime.
In our glass analysis, we're using the television glass and using the rifle P2 made in Korea and have a velocity of 920 meters per second. And the range of firing is about 20 meters.
So as you can see in this figure, the penetration of the bullet in the TV glass produces cracks which radiates outward or radial fractures that located in unload area of the glass, which is here. And encircle the hole or concentric fractures that located in load area of the glass. So here. So here is the point of termination located in load area between A and B. In the first hole, it has 13 mm, and the second hole, it has 17 mm. So by analyzing radial and concentric fractures pattern in TV glass, we can determine the direction of the impact. Radial fractures that located in unload area of the glass, which is here. So here is the unload area of the glass. As you can see, the exit area of the hole is much bigger than the entrance. The first hole has 60 mm and the second hole has 34 mm, and also in the exit area that located the radial cracks.
Production of the concentric and radial fracture in a TV glass. Radial cracks are formed first, commencing on the side of the glass opposite of the destructive force. Concentric cracks occur afterward, starting on the same side of the force. Radial fracture form the right angle on the side reverse. A high-velocity projectile, such as bullet, often leaves a hole that is wider than the exit, as you can see. Side, and hence, its examination is important in determining the direction of impact. That the direction of impact can also be accomplished by applying the tree rule, which is the radial cracks form at the right angle on the reverse side of the force. The sequence of the impact when there have been successive penetrations of glass is frequently possible to determine because of the fracture always terminates at an existing line of the fracture.
Good day everyone. Now I discuss about the glass fracture of this TV glass that hit by the bullet. So, this is the concentric fracture, a crack in the glass that forms a rough circle around the point of impact. Fractures that encircle the original entrance of the bullet. And the other side, the exit or unload area. The radial fracture is located. So, the radial fracture, a crack in the glass that extends outward like the spoke of a wheel from the point at which the glass was struck. A radial fracture is a fracture that radiates outward from the original entrance or load area of the bullet.
Yeah, man.